people really looked at what they call the coins and the tokens and trying to monetize that technology moving forward. But blockchain is actually has a good promise. It's, in a nutshell, it's a mechanism by which you can store the data in an encrypted fashion, but it's also a distributed network, meaning that the data is not centralized and in a single database or a single repository. It's actually decentralized and on a number of nodes that take part of the network. Now, why would we want to do that? Because building capability like this brings the ability to have tamper-proof data and immutable data. So imagine you put something in the blockchain. Once the data is there and has been validated, you cannot hack it or tamper with it. Now, in our cases, that makes a lot of sense because there's a lot of dispute, or in an ecosystem when there's a lot of dispute, or people have issues with fraud, having the ability to have data that you know you can rely on because it's not being hacked or tampered with, that actually brings a lot of benefits when you analyze the data, but it also brings a lot of benefit to the people putting the data in. I've said a lot about data, I've said a lot of things. I'll give you an actual real-life example. When I moved to Australia, I came on a working visa. So to come to Australia on a working visa, you have to provide a copy of your birth certificate, copy of your diplomas, copy of your other passports, and so on and so forth. So I provided all this to the Department of Immigration. I got my visa, I came to Australia to work. 3 years later, I applied for permanent residency. Guess what documents the Department of Immigration asked me? My birth certificate, my passport, my diplomas, and so on. I'm thinking, surely you could have kept all that information from last time, right? And then after 3 or 4 years as a permanent resident, I decided to go for citizenship. Guess what? They asked me what's the same level of papers again. So even though it's a positive story at the end because I am now a citizen of Australia, I have two major issues with that. One, I have provided the Department of Immigration with all that information. Now that I'm a citizen, what do they do with it? Is it sitting in a filing cabinet, and is somebody instructed that in 5 years' time they need to physically destruct the copies that I've given? Or is it just lying in there? Because nothing is electronic. When they want a certified copy, it has to be paper-based. I'm pretty sure they've got no links between the working visa, the PR, and the immigration, because they've asked me for the same information every time. But the biggest problem I've got with this is, how do I know someone's not using that information for fraudulent activities? Now, I have to trust the government, and I do trust the government. But at the same time, there's someone who's got a filing cabinet full of information of all those peoples. Do they actually do the right thing by me? Do they really discard that information? What do they do? So what blockchain can allow, and a lot of people are working in the identity space with blockchain, is actually reversing the model. I'm not going to give the information to the Department of Immigration. The Department of Immigration is going to ask me to give them access to a copy of my passport, or to the original of my passport, for a period of time. And when they are finished using it, because they need to do validation, I actually remove the access. So I regain control over my identity. Now, the ability to do this is to be able to have a system that you can prove the data in the system is tamper-proof. And that's where blockchain comes into play. So we can take the same example. I want to apply for my citizenship. I go to a certified agency, so a lawyer or someone that looks at my visa, looks at the copy that is on the blockchain and puts its stamp, the certification that we provide, and say, yes, I guarantee, and I'm a position of authority, that the data in blockchain is the valid data. So when the Department of Immigration or any other department wants to have a view of my passport, an airport, an airline, I give them a quick access from my phone or from my tablet. They log onto a website or an application, they enter that unique code, and they see my passport. And they trust the technology is actually providing tamper-proof data. Now, how does blockchain actually provide tamper-proof capability? So it does it via distribution. So instead of having a central data repository like a database, it's got quite a number of little servers or nodes around the periphery, and the data is actually replicated across all the servers. But this is where the name blockchain comes into play. My bit of information is sitting in a block, and each block are linked from one to the other. But they're not simply linked by just a reference. They've got a cryptographic hash, so this is where we start to be a bit technical. But basically they take the photocopy of my diplomas and my certificate, they bundle that into a packet of information. We encrypt it, we put it on the block, and as soon as the block is validated, that block gets replicated on all the little servers. Pierre comes along and does that. His information is on the next block, but the two blocks are links based on the cryptographic signature of the previous block. So the block starts to form a chain. So if I wanted to hack or modify the data that concerns me in block 12, I would have to not only change the data on one server, I'd have to change it on potentially 1,000 servers. Each block is timestamped, so I would have had to do it at the exact same time, but it's a chain, and the chain references the previous block. So I would have to also rewrite the entire history of all the blocks coming afterwards. Computing power at this moment in time is absolutely impossible to do those things. Doing it all at once, possibly, and again, but rewriting the history all in once as well, it's just impossible from a computing power process. This is where we come to quantum computing. A few people have said to me, oh, what about quantum computing? I don't know if you know about quantum computing. I don't know a lot about it, but it's extremely fast computing. When we get to a situation where we get to quantum computing as a service and people, Joe Block, can actually use that, then maybe we'll rethink the blockchain capability. But that's only for public blockchain. Like any other system, you can put a blockchain behind a firewall, behind a set of security rules. You can actually enclave it so hardly that no one that's not supposed to have access to it won't get access to it. So all in all, that makes the blockchain like super resistant to tampering, to attacks, and so on. Now, the other aspect of blockchain is the distribution of information, or the replication of the information that Pierre was talking about. So the data is not only on a single computer, it's replicated across all the computers. Once again, why would we do that? So another real life example. When I was moving to Australia, I was in the UK and I was banking with HSBC. HSBC is a world bank, so I walked to my HSBC branch in the UK and I said, hey, by the way, I'm moving to Australia. Could you possibly open a bank account for me in Australia before I get there? And they looked at me with big eyes saying, hang on, we have the same name, but HSBC UK and HSBC Australia, two different companies. We don't talk to each other, right? I was like, really? Okay. So I arrived in Brisbane and I opened an HSBC bank account. Perfect. Now, because I was moving a bit of money here and there, the best part of it is if I want to transfer money from my HSBC in the UK to HSBC in Australia, or vice versa, well, it takes 24 hours and they take $20 as a fee. Really? My money, same bank, it takes time and takes money. This is also what came up where Bitcoin kind of came into play. People were fed up in having those instances, those centralized institutions, and I agree, a bank is everywhere, but the institution is a monolithic pillar, and you have no choice but to deal with HSBC if you're banking with HSBC. It's not like suddenly I can transfer my own money. I have to go through them, which is a problem because I have to trust that the bank do the right thing by me. Now, I remember being a kid and my parents having complete trust in government, complete trust in banks. We're going to put our money in our savings and the banks are going to do the right thing. And then the GFC hit, and we heard about the subprimes in America, and we heard about all the people taking money. And so the trust that we had in those banks, I have to say, kind of went away a little bit. And you're always wondering, if I put my good-earned money in the bank, will they actually do the right thing for me? And same with pension funds and a few other things. So the idea behind the decentralized nature of blockchain is really to say, well, hang on, we don't need that centralized body. We can start to do operations without the bank. So back into my HSBC accounts, if I had a little application on my phone, and there are more and more applications that come to this place that says, well, I know how to talk to HSBC bank account here, and I know how to talk to HSBC in Australia here. And I have a blockchain, so if you put a transfer of money on this end, I will guarantee that transfer will not be tampered with. And then I'm going to transfer the money from Australia to the UK using the blockchain. A, that will take about 10 minutes, and B, it's not going to cost me $20. It's going to cost me a little bit of money because I'm taking part of the transaction of the servers, but we're talking 0.05 cents. So now the banks are having a bit of difficulty because they have the monopoly of the banking. They are banks, after all. But now more and more people are looking at different ways of not having to deal with it. So they're a bit scared about the blockchain technology. Another example where blockchain starts to be very interesting is around land ownership. So I would say in Australia, land ownership is pretty well understood, in France as well, and so on. But there's a number of countries in South America, for instance, where land ownership is been given from father to son through generation, but is it there? Is it there that my land finishes, and so on and so forth? So, and often enough, there's a lot of corruption, and people, usually large organizations with a lot of money, will start to say, well, you know what, just forget they own this land, we're just going to go through and, I don't know, mine or do something. So they're starting to use blockchain and actually put land ownership as they know it on the blockchain outside of governmental departments, because they do not trust the government to do the right thing by them. Once I say, well, my land started here and finished here, and I've got a deed paper that I've had by my local mayor or however I get it, I put it on the blockchain. No one can start to say, well, hang on, you've modified it. Because we can't, because the property of blockchain is that it's completely tamper-proof. So there's a lot of application of blockchain. Now to try and join all this back with certainly what C5E and Pierre is doing, it's also the story around incentive, giving an incentive to people to actually start to be part of a consortium. So in the little diagram that he really had multiple parties. So we had the tribes and the clans and the people in there, where the people who can actually provide the certification. There's the government, no matter what, whether we like it or not, we can't really do without them. And then
we need them for major infrastructures.
Absolutely, I'm not disputing, and you know, there's plenty of good. There's only a little bit of bad that sometimes makes the good not so prominent. And as I understand the whole ecosystem, there's a bit of a problem because large organizations who need to go and operate on the land need to compensate the people from that land. The problem is, how do we know for sure that the value that they're supposed to give back to the people is actually the real value that they give back to the people? Where is the traceability? Where is the governance? And how do we know? One of those things that we see is the fair trade coffee. You know, you go to the supermarket, you say, fair trade, great, I feel good about myself. How do I know it's not just the supermarket that put a sticker on it? I as a consumer, I have no way of knowing for sure. And supply chain is a good call for blockchain. So imagine a scenario whereby we know, I'm going to say Total or Exxon, even though I probably shouldn't name them, they need to put this pipe here, and we know they will need to cut the trees in the middle. Okay, that's how it. So one of the things to fulfill this agreement is to know what is the level of deforestation that is actually happening. Because 5 years ago on the plan we say we'll take only 20 meters because that's all we need. But the reality is that we take 30 or 40 meters. And I'm making this up, don't quote me on this, but we're taking a little bit more. So what do we do with this? So we can send drones to start and survey, and we can probably have other mechanisms. Pierre was telling me that often enough they send students to come and do a bit of surveying and talk to the tribes. But how about we enable the people that are on the ground, the tribe people and the clan people, to actually do their own reading and say, okay, here's a mobile phone. We've got a tiny app on there that says, take a picture, record your location, put a number of trees that you see, and send. Okay, that's a good idea. Why would we want why would they want to do this? How do we incentivize them to actually be taking part of it? There's a few ways to do, but knowing that the data they are providing is actually beneficial. But how about we go one step forward, further? If we say, if you take a reading every week, we'll give you a coin or a token. It's not $1, it's not a kuna, it's just a unit. A bit like when you play a video game and you've got 20,000 points. And we say, well, when you get to 10, you can actually look on that list and you will get something that you actually need. Not dollars, not money, a book, a pair of shoes, a shovel, whichever they actually need. Now that you've got those people incentivized around being part of the system and doing good reading, we can say, well, okay, this guy is taking a picture every day, but honestly, the picture is blurry every time, so this is not good recording. So now you can start to bring gamification at this end and say, okay, who's the top person giving good data? And we're going to start reading. Kids love it. That's the Candy Crush of this world. You've got 5-star, you're the best in your tribe or the best across the tribe and so on. So we're giving the token and the intent is to give something up. But how do we get that something back to them? Well, the good data that we're actually collecting, the data that has not been modified, that's very important now for the large organization, for government and certification agency. We can go back to, say, Total or Exxon or one of those large organizations and say, well, okay, if you give us 200 books, I'm going to take the book example, to learn to read or math books or so on, we'll give you 1,000 tokens. And guess what? With those tokens, you can actually start to query the data. So now we start to have the people who take the reading get those token credits. The organization that are interested in the data purchase the credit, but against goods, not against dollars, and goods that are actually needed for the people who are actually taking the data. The fact that the data in the blockchain is tamper-proof and really good data, and you can start to not monetize the data because it's not in terms of dollar, but you actually have a bartering of that data versus goods that start to come into place. And you extend the ecosystem to government to do some validation, to certification agency, and so on and so forth. And suddenly you've got an ecosystem where there's actually no real physical dollars that are being exchanged. It's just good versus services. There's an enablement of technology for the younger generation. There's a great idea that came across with languages as well the other day. Actually this morning with Total, to say, well, if somebody in a tribe does a recording, how about he does it in Pinji, but it also does it in the language of his parents? And now you start to track the old languages that start to die in the forest. And there's plenty of ideas. That's part of my 70 million ideas that do that. But the beauty of it is that where blockchain really sits and has a real benefit is around when we're in an ecosystem, when there's a lack of trust and a potential for fraud. Blockchain can really support removing that element of fraud because the data is guaranteed to be the data that you actually put in. Now, I need to say a little thing. If you put rubbish data, you get rubbish data on the other hand. So there is a way whereby we need to try and enable people, but also let them want to put good data because they get something in return. And that's where the whole ecosystem of blockchain actually comes in. And then what cannot happen is Total or Exxon or a large organization say, well, I actually think that data is not the right one. It's been modified for purposes. And you say, well, no. With the app, we can say, we know where they are. We can see the picture. We know it's been uploaded at the time the picture was taken. And they say there's 7 trees. You cannot come and say that there's 20 or 50 trees now in this area. And so we're working on that ecosystem to actually so the proof of concept that we did on blockchain here, we actually put the blockchain in a private cloud effectively. So all the little machines that run, they're all in the cloud. They're scattered around the world. We started with only 3 because we were just doing a proof of concept. But to reassure the various parties that take part of the system that they own the data, physically own the data, You could use a small device. I don't know if you've come across the Raspberry Pis. They're like little microcomputer, and having a single node of a blockchain network running on a Raspberry Pi is actually possible. And so you could give one of a clan or the tribe. Now, they do need connectivity to some Wi-Fi or 4G to some extent, and I know there's a technical challenge there. But the ones who can, they physically have the full blockchain data on that little device. So if somebody says, oh, we don't believe that, you say, well, hang on, I've got it here, and let's compare. I can compare my data on my Raspberry Pi with your data and your data, and we'll see if we all have the same data. They should be, because the blockchain ensures it. But if somebody tries to modify that data, you've got a mechanism where they can actually compare. And they physically have the device with them.
So if
Just
you
one-
get
one
the
minute.
yeah.
And to go back to that technology is not, we were talking about various and drones and so on. We're trying to really enable the people on the ground to know that they actually make a difference by providing good data and get a reward for it. But that technology is in combination with drones, with IoT, with all things, because the more data you get and the more data comes to the same result, the better outcome and the better analysis you get on the data. So that's why we ended up talking about drones with Total this morning, because the human factor is one thing, but as much as you try and motivate people, sometimes humans are a bit unreliable, and you can augment that or augment drone vision with what the people are seeing on the ground as well. So it's a combination of a lot of technology. One of the benefits of blockchain is to bring back the trust into the actual system and the process. To be able to build trust, we need to minimize effectively the time between the data being recorded and the data being put on the blockchain. Because the longer there is, the more chances there is for human tampering. A good example is really a picture that I would take. So if I take a picture here and I see it on my phone, that's the picture I've taken. But if I take a picture here, I send it to Pierre, and then I send it to you, Goodwill, and it comes back, and then it's not quite the same picture because it's been photoshopped. I'm not too sure which one has done the photoshopping type of thing. But if the data gets onto the blockchain straight away, we know the data is pretty much good. Once it's on the blockchain, the properties of the blockchain makes it stamp-proof, but that capability. So what we wanted to try and limit is the time between when somebody does a data recording. So they're probably on their phone with a little app in the forest. And then we were thinking having a small Raspberry Pi that is always connected to the network. So as soon as they come back closer to the Raspberry Pi, the data is actually synced and then put in a block that gets on the blockchain. Now the problem is sometimes we don't always have connectivity everywhere. So having this short time frame capability where you could potentially lift and pick the Raspberry Pi to an area where there is connectivity, or lift it up in the air so suddenly we've got like a 4G signal, then the length of data between the data being recorded and the data being on the blockchain is actually minimal, hence bringing back the trust that there's no tampering with any data being done. So that was one of the ideas that we had. There's definitely other ways that we can do it, but there's probably actually a better benefit that we could start to look into that. If we start to see that people are tracking and recording the data properly, we can also decide that there's a way of incentivizing that data recording by actually providing more mobile cell coverage. And instead of saying we're going to give you books or we're going to give you, I don't know, a shovel or something that they also need, but we can say, well, how about if commonly you get to 1,000 tokens, we'll actually create a tower cell in your area, or we'll give you credit for your phones to actually use it. So there's plenty of ways to really get the connectivity and the technology back into the community. Okay, so in terms of the demo, I think we can see. So that's the website that we put into place, and what we're seeing in here. So it's a bit of a landing page demo site type of thing, but what we wanted to show is the interaction with the blockchain here. So here, that's not going very well. Here we've got, it's a bit, the contrast is not very good on the projector, but basically this is the address of my blockchain here, and it's running locally. I know it's running, and I'm going to deploy the C5 the contract. So the interesting part with blockchain is that initially, due to its immutability, only data was being stored. And then some very clever guy thought, well, technically a program or a script is actually also data. But the beauty of a program or a script is you can actually run it, feed it input, and get output out of it. And so he started to call that a smart contract. It's actually a computer program, but the beauty of it is once it's in the blockchain, no one can change it. So it's not like you've got an Exadata hacked or anything. It's in there, it's immutable. You can certainly modify it by making changes through different blocks, but the history of the changes to that program is always recorded. An example would be, I'm going to say, well, every time a recording is done, I want an email to be sent to me. And then Pierre will say, well, I actually want the email to be sent to me as well. So I make a modification to the program, but the original code is always on the block before or a few blocks before. And that's the beauty of it. You've got that traceability of all modification to the program as well as modification to the data. So the first thing that I do is I load up the contract. It's called a smart contract, but it's really a computer program, and I'll show it on the other. And if we see things are going to start to happen. Yep, yeah, blah. And that's the web app talking to the blockchain in the backend. One of the big properties of everything, I know it's a little bit small on the projector here, but each block provides what we call a transaction hash. That's a unique encrypted value from the data that we've put in. If I change a single character of the data, the hash completely changes. So that allows me to say, well, if I look at the computer code now and I hash it with the same algorithm, do I get the same hash I had in that block? If yes, it's not been changed. If no, somebody's trying to tell me something else. So once it's deployed, the UI changed a little bit, and I see the current block is current block 1, and this is where my contract is stored. I can do a quick test. That clicks to the blockchain, and it says, yeah, it's okay. If I look here, we see that the eth call was to the test. It's a bit hidden there, but I can do it. Okay, so the next thing we're going to do is we're going to create a tribe. Okay, so currently there's none because I just started the system. So I'm not going to be at all creative about my namings and my test data. So I'm going to call it T1. I'm going to say it's in PNG. No, what did we say? The Gulf Province.
That's where we're from.
Oh, okay. I didn't even know that because they told me there's
the LNG site.
Okay. And it's in PNG, for instance. So when I'm going to create the tribe, what's going to happen is I'm going to package that information into a block. I'm going to put the block on the blockchain. The block is going to get replicated around the network, and I'm going to be given a single hash for that block in particular. So if at some point someone says, well, actually you didn't put 10 in the population, you put 12, I can put that exact information into the hash and I won't get the same data. I can also look at the data back in the block and say, well, he said that he put 12 initially. I can tell you no, we actually put 10 in the number of population because I know that at this point in time, this is the data that was put into the blockchain. Create that. I'm going to try and quickly things are going to happen there, blah, blah, blah. So now we're on block 3 because we're calling the method and then we're storing the data. So 2 blocks get created. And if I go back to my little technical info there, it's going to tell me at the bottom, we're on block 3. Okay, so now I'm going to go back to managing the tribe. There's another thing
So what was block 2 again?
So one is the call to the smart contract, and then so effectively it's the data in and then the data out type of thing. So it splits it in 2 blocks.
2 transactions.
2 transactions, exactly. And that's what blockchain is about. It's around transaction. The funny part with smart contracts, it's a one-way transaction. We put data and then we get data, but it's 2-block type of thing. The other thing to mention is what we call the gas price. So what I find interesting in software and in IT, we've reused a lot of the engineering tools like designer, architect, and so on. On blockchain, they used a lot of terminology from the mining industry, Don't ask me why. So we have miners and we have gas and a few other things. But even though when I was talking about transfer from HSBC to say if I was doing my own transfer, I wouldn't charge myself, there is still a cost of the underlying network and infrastructure. And in blockchain, that's represented, or in Ethereum blockchain, that's represented by what they call the Y. And basically, it's an average value of, if you're running a server with blockchain on it, you still have a cost of electricity, you've got a cost of maintenance and a few others. So all the servers have a slightly different cost of maintenance, especially if you run in China, for instance. Electricity is much cheaper than running, say, in Australia. So the cost of a single transaction varies by server, and it's represented by Y. Y is the kind of metrics of how much a transaction costs. And so blockchain is not free. It lowers the transaction cost, but it's still, you have to pay for things. On probably a final point on this is also where you've got a difference between public and private blockchain. So a public blockchain typically is hosted in the cloud by a company, and they will say we have 1,000 servers that are all the nodes in the blockchain infrastructure. Based on that, they will tell you on average a transaction cost X amount of Ether or Bitcoin or dollars or something. In a private blockchain, your transaction cost is actually doesn't cost you anything, but it's your responsibility to pay for the servers, to pay for the network, to pay for the firewalls and so on. So there's a cost no matter where we look at it. What we don't need is a cost of manual interventions, overall process that people want to apply in it, because you can code that into a